back again. So in this video we'll be talking about the Vokera Easi Flow. In 25 years I've only ever installed one. I'm quite impressed with this appliance, it's quite good. It seems quite basic and sturdy. Enjoy the video, any comments put below, like and subscribe. Wow. How it functions. So the Hall sensor activates the gas valve, and this is quite a little interesting burner setup here. So cold water comes in, activates the flow switch, Hall sensor comes up, and it's almost got like a preheat. Look at that, look. So the cold water comes in, preheats under the burner, goes through the heat exchanger, and comes out again. So that makes this product so much more efficient. All combis, all they do is heat the water up 35 degrees. They don't heat it to a temperature, they heat it to 35 degrees. So theoretically speaking, this appliance, it won't know the difference in seasons, because it's got the preheat under the burner. You know, so for example, in winter time, water comes in at 10 degrees, you'll get probably 45 degrees hot water. Summertime comes in at 20, 55 degrees, etc, etc. So that's a really interesting preheat concept. So before I get a multimeter out, let's quickly have a look at the appliance and go through the bullet points of what can go wrong with this appliance. To be fair, it does look quite a good product. I am quite impressed. So I am actually impressed with this product. It is good. It does look solid and sturdy. Let's begin. Very rare these go wrong. These are a good solid product, decent technology. The only thing that concerns me is putting a compression brass nut on that thread. Other than that, good product. Gas valve might seize, fail. You've got a high limit stack there that could go wrong. Burners, keep them clean, vacuum them. Electrode could warp. This ceramic shaft could crack, HT leak could spark on the burner, miss it. Burners could warp. Insulation pads could fail, fall on the burner. These could block up with soot or scale, so light above, push them up down. on some covering here to protect the burners. Never push up because you could block it on the top. On the side, you've got a high limit stat. Heat exchanger, that could scale up. That'd make a popping noise, won't it? Fan, the bearings could seize at the top here. Here you got air pressure switch, that could fail, that could seize in the open or close, and the tubes could become blocked. They could get maybe water or condensation in there, which could stop the appliance firing up. Resistance is, we'll say 54 ohms.
The NTC.
You can just see how it touches the surface. So sometimes with these, you can just move them slightly and they overhaul, because sometimes that little surface misses or gets dirt on it. It's set to 20k ohms, which is the horseshoe look. Horseshoe, 20k ohms. Disconnect the cable. .20k resistance. So, earth, number 1 is neutral, 3 and 4 is for the valves, solenoid valve. .3. Here, we're going to the top one, second from the bottom. Here, gone from the bottom to the top. .85. And now, we're going to do this solenoid. This is a modulating solenoid. This is the modulator, so basically I think that'll help the flame fluctuate. For the modulating solenoid, I've changed it to 200 ohms resistance. I've gone to the top 2. So here we have the high limit stat, and we have one on the burner. So for these, just check continuity. So the air pressure switch, you can blow down it and check the continuity if the relay switch is moving, because it should go to normally closed, normally open. Another simple way is check the hoses are clear, put your U-gauge tube on and just blow down it, and that might alter the performance of the boiler. If that's seized off, the boiler won't fire up. So this tip is to clear scaled up Lurlos headers, plates and heat exchangers. So that heat exchanger is copper. So if it's in a hot water area, that's going to block up within years, might even pinhole. So get a pump. So the heat exchanger is blocked up perhaps. Turn it around and put the shower pump on it. So when it's pumping water in, the water turbine, the flow switch, will fire up. So you'll have the shower pump with the descaler in, and it will pump it round, and it will fire up. So you've got warm descaler in there, and that'll activate it. So This pipe, you turn around and you connect to a cistern, so you're circulating it. So, descaler pumps it through the heat exchanger and back in. So it's cycling descaler through the hex low loss header.